Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so today we are now in the second lecture of part 2 of topic 4, matrices and system of linear equation. So as you see on the screen here now, 4.2, determinant of matrices. Okay, so before we continue, then I do hope that all of you again, please do support my channel if you're willing to by click the button of subscribe button, share, like, and notification bell button. So hopefully that you'll get the latest and the next videos from my channel for your own goods, okay? Helping each other then. Okay, so I do hope that my videos benefit you for your studies and help you in your whole studies of the semester. Okay, learning outcomes. So we are now focusing on wait a minute. Okay, find the minus and cofactors of the matrix and find the determinant of a matrix of, okay, we're focusing on a matrix of 3 times 3 using cofactors. Okay, so this is your previous knowledge, determinant of 2 times 2 matrices. Okay, we are going to find the determinant of what we call 3 times -1 equal to -3 minus 5 times 1 equal to -5, that is in -8 here. Okay, now the minor is a determinant, Fij is a determinant of these matrices obtained by deleting the ith row and jth column of A. Okay, so class, this is a matrix of A with element of A11, A12, A13 until A33. So the minor here, okay, we come up with, okay, look at the, we call the column of this, okay, for this symbol is we call a bracket, but then this symbol here now, it looks like a determinant, okay. But it's not a square root of x squared plus y squared. It's not something. It's not that. Okay, for matrices, it's different. Okay, so we call to find the minor of Aij and until minor of A33. Okay, so this we call, we delete the ith row and jth column. So this is left. So then, this is the one that we're going to multiply, cross multiply A22 times A33 minus A23 minus A32, multiplied with A32. Okay, so then here now, A22 multiplied with A33 minus A23 multiplied with A32 here. And cofactor of element Aij is given as writing here. Okay, so -1 to the power of Ai plus j and the minor. So find the minus and cofactors of A11, A21, and 32. So this is a matrix of A given here. Okay, the minor of A, okay, the minor is the determinant of 2 times 2 matrices. 2 times 2 matrix obtained by deleting the first row and the first column of A for minor A11. So minor of element of A11, which is M11. Okay, so this is a matrix of A. So we delete the first row, first column, and the first row. So what you can see, what can you see here now? It's 4, 2, 4, 3, right? Okay. And then we just imagine that it's a 4 times 3 equal to 12 minus 2 times 4 equal to an 8. Okay, so 4 times 3 equal to 12 minus 2 times 4 equal to an 8. Then 12 minus 8 equal to 4. So minor of M21. So we are referring to the, we call the element of A11, deleting the M21. So deleting the second row and the first column. Okay, so we can see here now, it is 2, -1, 4, and 3. So then, 2 times 3 equal to 6 minus 4 times negative 1. Okay, I will write it in a proper multiplication. So then 2 times 3 minus negative 1 times 4. So then 2 times 3 equal to 6, negative and negative positive, 1 times 4 equal to 4, then it equal to 10. Okay, and this one here now, M12, so delete the first row and second column. So what's left here now? 3, 2, 1, 3. So then 3 times 3 equal to 9, or 3 times 3 minus 2 times 1. And 3 times 3 equal to 9 minus 2 times 1 equal to 2, and it is 7. Okay, there you go. Okay, the cofactor the cofactor of Cij of the element Aij here. So we just now we learned how to find the minor. Now for cofactor, it is negative 1 power of we call the element of I and j for this one here, which is 1 and 1, so 1 plus 1 equal to 2. So class, negative 1. 1 plus 1 equal to negative 1. 1 plus 1 equal to 2, which is 1. Negative 1. 1 plus 2, or negative 1 to the power of 3 equal to negative 1. Negative 1 to the power of 2 plus 3, which is negative 1 to the power of 5 equal to negative 1. Okay, so then here now, the minor of 1, 1 equal to 4 just now. There you go. The minor of the M11 equal to 4. Meaning, we're going to bring up this for 10 and 7 also in next example here. So then, so negative 1, 1 plus 1 equal to 2 times 4. Then negative 1 squared equal to 1 times 4 equal to 4. Okay, sorry. Equal to 4. And what about this one here now? Okay, just now we found that the minor of M21, the previous slide, which is equal to 10. So then 2 plus 1 equal to 3, and negative 1 power of 3 equal to negative 1. Then multiply with 10 equal to negative 10. And then negative 1 cube equal to negative 1, and the minor just now is 7 here, multiplied with 7 equal to negative 7. The minor, okay, we might find the minor of every single element inside the matrices of A. Okay, so just now, let's say this is a matrix of A, so we got A11, A12, A13, A21, A22, and A23, A31, A32, and A33. Okay, so this is a matrix given here, so we may find the minor of every single minor from M11 until M33. Okay, so the previous example, we just found that the first three of the, we call minor, so you may continue the rest. And cofactor, every single minor that we get here, here, this one here, Okay. We multiply with negative 1 to the power of I, what we call 1i plus j. Row, the number of row and the column. This is column row 1 and column 1. So 1 plus 1. So class, actually that for this part, okay, for example, for this one, okay, for this also, we may simplify this with this, with this pattern, plus, minus, plus, negative, positive, negative, positive, negative, positive. Okay, 3 plus 1 equal to 4, negative 1 to the power of 4 equal to positive 1. 3 plus 2 equal to 5, negative 1 to the power of 5 equal to negative 1. Meaning, the summation of I plus j, if it is an even number, then it come up with a result of positive 1. And if it come up with odd numbers, I plus j, 1 plus, okay, 2 plus 1 equal to 3. If in odd numbers, then it gives you negative 1. There you go. Okay. So find all the minors and cofactors of A and hence form the matrix minor of A and cofactor of A. So now, M11, so we delete the first row and the first column. So 1, 1, 0, 3. 1103 here, 1 times 3 minus 1 times 0 equal to 3 minus 0 equal to 3. And M12, delete the first row and the second column, you got 3, 1, 2, 3. So then 3 times 3 minus 1 times 2. Okay. 3 times 3 equal to 9. 1 times 3 equal to 9 minus 2, 7. Okay, 1 and 3. Minor of 1, 3. So delete the first row and the third column. Then we get 3, 1, 2, 0. 3 times 0 minus 1 times 2. 3, 0, 0, 1 times 2, 0 minus 2, negative 2. So then M21. So delete the first, second row and the first column. You get 2, 0, 0, 3. So then 2 times 3 minus 0 times 0. 6 minus 0 equal to 6. And delete the second row and the second column that you see here now. Clearly it is 1, 0, 2, 3. Okay, so now it is 1 times 3 minus 0 times 2. So 3 minus 0, 3. And then M23, and it is 1 times 0 minus 2 times 2. 0, 4. 0 minus 4, negative 4. Then next, M3, 1. Delete the third row and the first column. So you can see here now is 2, 0, 1, 1. Okay, so 2 times 1 minus 0 times 1. 2 minus 0 equal to 2. Okay, so in here now, 1 times 1 minus 0 times 3, 1. Okay, so 1 times 1 minus 2 times 3. Okay, 2 times 6, 1. 1 minus 6 equal to negative 5. So class, we have found out all the minor for every single element. Okay, Now we will list down all them here. 3, 7, 2, 6, 3, negative 4, 2, 1, negative 5. 2, 1, negative 5. Okay, negative 4, 3, 6. Okay, I think that all of you have recalled. Write it on your lecture notes. You may just check by yourself. There you go. So these all the minor from the matrices of A. So then multiply for this minor. To find the cofactor, we just multiply with the sign of positive and negative, and this is your cofactor of A. Okay, conclusion. So to find the minor and cofactor, and now cofactor expansion. Okay, and also we call the cofactor expansion along the jth column. Okay, for this one here. Now, if A equal to the matrix of Aij, the matrix of the size of 3 times 3, 3 rows and 3 columns. So then, okay, for this one here, cofactor expansion to find the determinant. Okay, class, we need to find out the determinant of this. Okay, expanding the first row here, A11, C11 plus, okay, element in the first row here, A11, A12, A13 multiplied with a C, cofactor of 11, cofactor 12, and cofactor of 13. Okay. What is the, okay, this we call the matrices of A. Okay, there is no value yet. We just show that this expansion to find a determinant. A11 multiplied with we call cofactor of 11, and also you see here. Okay, example 3, these are matrices of A. Find the expansion, we call determinant of A by expanding along the second row and the first column. Okay, this is a matrix of A, expansion along second row. Okay, so it means that it is 1, negative 2, and 7. This one, A21, 5. Oh no, not 5. Sorry. Okay, A21, here, 1. A22, negative 2. A23, 7. Okay. Then, the cofactor, there you go. The same process to find the cofactor, you need to find the minor first, where the minor for C21, delete the second row and the first column. So you see the left is negative 1, 4, negative 1, 10. Negative 1, 4, negative 1, 10. And for this one, 2 and 2, we delete the second row and the second column. So what's left? 3, 4, 5, 10. 3, 4, 5, 10. Okay, so this is it. So then, 1, and the result of this, negative 1 times 10. Okay, this is, okay, negative 1 power of 3 is negative 1. And then, negative 1 times 10 equal to negative 10 minus 4 times negative 1, negative 4. Plus with negative 2. Negative 1 to the power of 4 is positive 1. And then the minor here, 3 times 10 equal to 30 minus 4 times 5 equal to 20. plus 7. Negative 1 to the power of 5, negative 1. 3 times negative 1 equal to negative 3 minus negative 1 times 5, negative 5. Okay, negative become positive. Negative 10 plus 4, 1. Negative 1, negative 10 plus 4 equal to negative 6, negative 2. 1. 30 minus 20, 10. 7. Negative 1. Negative times negative, positive. Negative 3 plus 5. Negative 3. 3 minus negative 5. Okay, negative 3 plus 5. 2. So negative times negative, positive. 6. Negative 2 times 10, 20. And negative, positive, negative, 7 times 2 is 14. So then, 6, negative 20 minus 40, negative 34, plus 6, negative 28. Okay. Let's see if we expand it along the expansion along the second row, and the result is negative 28. What about expansion along the first column? 3, 1, 5. Okay. So, A11, 3, A21, 1, A31, 5. So then we got 3, 1, 5. And cofactor, negative 1, 2, 1 and 1. 1 plus 1 equal to 2, yes. And then this 3, and then this one is 4. Okay, so then 3, negative 1 square is 1. Now, negative 2 times 10, negative 20, minus 7 times negative 1, negative 7. Plus 1. And negative 1 cubed, negative 1. Negative 1 times 10, negative 10, minus 4 times negative 1, negative 4. Plus 5. Negative 1, power 4, 1. Negative 1 times 7, negative 7, minus 4 times negative 2, negative 8. Okay, so then now, 3 times 1, negative, positive, negative 20 plus 7, negative 13. Okay, negative become positive. 1 times 1 equal to negative 1. Okay, this 1 times negative 1 here. Negative 10 plus 4, negative 6. 5 times 1 equal to 5. So negative become positive. Negative 7 plus 8, 1. So 13 times 3, negative 39. Negative become positive. 6 plus 5. So then negative 39 and 6 plus 5 is 11. Negative 39 plus 11, negative 28. So let's double check. Is negative 28 here? And just now, it's also negative 28. Meaning, to find the determinant using minor and cofactor for every, okay, you may use even second row, the first row, third row, first column, second column, or third column. It will give the same correct answer. Okay. You may try yourself expansion using the third column and tell me if you get negative 28 or different. Okay. So then here, choose the row or column that has the most zeros. Okay. There are some cases where they give you a matrices of, for example, here 0, 5, 1, 2, 0, 0, and 1, 3, negative 2. Okay. The reason that we suggest to you to find the expansion of we call the most zeros here, that's 0 and 0, because 0 multiplied with any value of minor or cofactor, it will make our life easier, that it gives us still 0. So we only find the we call minor and cofactor for just one value, 2 multiplied with the cofactor. Then this one multiplied with any cofactor, 0 and also 0 here. Okay, so this is our target now. You may use second row or you may also use the first column. Either one. Okay, for this example, they use the second row. Okay, A21 is 0. A22 is also 0. A23, 1. So 0 multiplied with cofactor, 0. 0. Then this one only. So then this one, negative 1. Negative 1 power of 5, it is negative 1. So negative 1, 2 times 5 equal to 10 minus negative 1 times 0 equal to 0. So negative 10. Okay, so that's all for today, which I think that this is the end of the the lecture for this part. And again, once you watch my videos, don't wait, okay? Just try the few questions that parallel to the lectures that I gave you in this video, and try the question in tutorial and pass your questions. And that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.